Hi, in one of my video we discuss about what is cache and what are the different factors we need to consider when we design a cache, something like what is the size, what is the eviction strategy, when do we really need to store in cache. All these things we discussed as part of another video. In this video I am planning to discuss about what are the different implementation types for a cache. Okay, to start with, we have a embedded cache. um, so in this scenario we save the data in the same application server, like we consume some of the memory of the RAM and save the data in the RAM. Okay, and cache the data in the RAM. Okay, so the advantage of this approach is, since the application server and the cache staying on the same machine, okay, we have a very good latency. Okay, but on the other side, like if you want to scale up, right, if you want to scale up the memory, then there is always a limitation, because you need to add more RAM, and there is always a limitation in adding more RAM in a particular machine, and that cost a lot also, right? So from a cost wise also it is very uh, not possible. Okay, it is there's a limitation. Okay, so that is a disadvantage of this particular approach. Okay, so if you really want to scale up your cache, then you need to go and think about a client server architecture, where you can deploy your cache in a different server. uh, you can scale up that server vertically or horizontally. Okay, using the sharding or using the partisans, right? So you can do all those mechanisms if you take this cache and deploy it in a client different server. Okay, so in this case the application server acts as a client, and whenever it want it from the data from the cache, it will go to the cache and get it. Okay, so in this case what is happening, um, the advantage is like you can scale up really, but the drawback is you need to go all the way to over the network to your server, the cache server, and get a data, right? So the latency will be hit. Okay, in this case, like, so that is a drawback. So you need to trade off between the latency and the scaling factors to decide whether you need an embedded cache or a client server architecture. There is an approach where you can get a better performance, and also you can do a cache using the sidecar cache, where it is doable in the container architecture, where you have different pods. Okay, so as a pod you can always scale up your pod, right, both horizontally and vertically. And also your memory is going to distribute across the pod. Okay, so in this approach, like the latency will be good, and also you can scale up the pod, right? So that is a advantage of this particular design. But the drawback here is it is limited to a container architecture. You cannot implement the same for a legacy architecture, right? As a container you can always scale up, right? But as a legacy the scale up is not possible. So that is a drawback of this. That is actually not drawback, that's a kind of a limitation for this approach. Okay, so in all this technique, in these three techniques, like embedded cache, or it is a client server, or it's a sidecar or cache technique. Okay, we are saving the data either in the application server or as a different server, right? But there is one more way, like called a reverse proxy, where we cache on the load balancer. Okay, it can be at Nginx, or uh, it can be at the Zulu for the Spring Boot, right? So we are going to save the data in the load balancer. So when a request comes in, the load balancer will check where for this request whether we already cached the data. If so, like, it never go on the application server, the request will be dispatched from the load balancer itself. Okay, so that is another kind of implementation, but there is a lot of limitation for this, like when a request comes in, at the request level itself you need to you are finding, right? And this approach is followed for certain use cases, but not for all the use cases. No, not we cannot implement this approach for all the use cases. Okay, for example, if it is a kind of a static data, we can store at a load balancer level, and we can cache it and return back to the client. Okay, but at a transaction level data, like for each user perspective, like if we want to return the data, this design may not work out. Okay, And the limitation for this technique is it is a protocol based. Like if you mostly like with the HTTP you can do it, okay, but with other protocol I don't think we can really implement this approach, okay. So that is a drawback with this particular approach. So we have discussed about what is embedded, what is this client server architecture, what is sidecar, the container based, and what is the reverse proxy caching technique using the load balancer. um, so it depends upon your application scenario. You need to choose among one of these. Like the easy way is embedded, and if required you can go with a client server, okay. But the easy and other, if the architecture okay, you can always choose the sidecar, okay. You can create a pod and deploy your cache in a pod. And the static data, so you can think about loading that in the load balancer. Hope you guys are good with this video. Thank you.